Hey everyone, welcome to your Algebra Play Pause It for the day. We're going to be going over simplifying radical expressions. So kind of taking what we learned last Tuesday in our live class and going a step further. So we don't have any specific notes for today because they're kind of just a bunch of examples. So I would suggest go ahead and grabbing some notebook paper from your math notebook or writing on the back of your notes from last week if you didn't print on double sides, and we'll go ahead and get started. We're just going to work through a bunch of examples together. And I'll remind us here at the beginning, don't forget that if you want to at any time, you guys can pause this recording, whether you're in the Play Pause It or you're watching the View Pure link. You can pause it at any time. So again, we're going to be working towards simplifying expressions. And I have a little sneak peek of the gingerbread assembly that we did on Friday. I'm going to show you guys in live class tomorrow the winners from each grade level. They were awesome. So here is our flashback for the day. Here they give us an expression with some variables, right? A, B, and C. And they want us to substitute in these values. So let's go ahead and do that. A is 8. C is -4. B is 16 plus 9. Now you guys do have the Desmos calculator that you can use, remember. So I did show you guys last class where to find the cube root and where to find the square root, but let's do it by hand because we are going to need to know how to do some of these by hand. Not all of them. You can see that these answer choices are whole numbers. And so they really do just want an answer. You'll see some today where we get to a simplified form, and maybe you've seen some of those in your OMHS. And in that case, we would need to use more of our brains than that calculator. So this is a cube root. Remember, we're looking for 3 numbers then that multiply together to give us 8. And they all have to be the same. So sometimes it's helpful. Over here, you can do a little factor tree. What times what is 8? 2 times 4 and 2 times 2. So these hanging fruits here, these are our prime numbers, which means they can't go any further. The only factors left are 1 in itself. So we're done with that factor tree. So there are 3 2's. So there you go, you found it. 2 times 2 times 2 is 8. It's a perfect cube. Let's keep going. Negative times a negative is a positive. And here we have the square root of 16. So now we're thinking of 2 numbers. Square root. Remember, if there's nothing written here, there's an implied 2. And we want to think of 2 numbers to give us 16. You might already know them. Or we could also do a factor tree. You can think of any numbers. Oh, well, I maybe first thought of 2 and 8. 2 is done, right? That's prime. 8 keeps going to 2 times 4. That 2 is done. And 4 goes to 2 and 2. So you can see we have 4 2's here. So maybe you recognize that it's 4 times 4. 4 times 4 is 16. We can also write it out as the 4 2's that we found. And then remember, with square roots, you're looking for pairs of numbers. So we have that pair and that pair, which simplifies to the 4 and the 4. So either way, however you like to write it. And then, of course, we have plus 9. So let's keep going now. We have 5 out here in the front. When we take the cube root of 2 now, the cube root of 2 is, the cube root of 8 is 2. So that 2 comes out. That's all you got there. Because remember, cube root is like an operation. So we went ahead and we did it. When you take that cube root, one of these come out and essentially it kind of disappears, if you will. Kind of a strange math term. Okay, the next one here, we have 4 times 4. Those are those 2. So the square root of 16 is 4. If you did it this way from the 2's, you would say, oh, here's a pair of 2's. I'll take 1 out. Here's another pair of 2's. I'll take 1 out. And 2 times 2 is 4. The same 4 you get here. So either way that you do it. Now let's keep going. Order of operations, right? Parentheses and multiplication. 5 times 2 is 10. 4 times 4 is 16. And we can add these all together. Get 26 plus 9. And then 26 plus 9, what is that? 35? You guys can double check me. I will too. So it is B. You could definitely plug this into your calculator. Just be careful with parentheses. Make sure everything is where it needs to be. So like I said, today is just going to be a bunch of examples. We're going to work through them and feel comfortable at any time. You guys go ahead and pause and you can try them on your own. So the first one I want to review is square root of 4. So we've kind of already done this today. We definitely did it last class. We're looking for two numbers that multiply together to give us 4. And we know it's 2 times 2. And we're looking for numbers that are the same, right? 2 and 2. So we have a pair of numbers. And with square roots, you're looking for two numbers. So here they are. Square root of 4 is 2. Take it out. That's the answer. This is known as a perfect square. How about square root of 16? Did we do that one over here? Yep. Square root of 16 we know is 4 because 4 times 4 is 4. All right, so this is kind of a review from what we did last class when we're looking at perfect squares. Maybe we should also quickly review the square root of x squared. So remember, you can do the same exact thing with variables. X squared is the same as writing x times x, and we have 2 of them. So we have a pair of x's, so 1 comes out, just like all the other examples we've done with numbers. All right, let's get to some new examples. What happens when they're not perfect squares? Like, what about square root of 8? And offhand, we know that 8 is not a perfect square, so we have to find a perfect square that lives inside it. So I like to do factor trees again. Think, what two numbers multiply together to give me 8? There's a few options here. I go straight for 2 times 4. Some people might go 1 times 8, but then you got to break that 8 down. So again, 2 is prime, so we're done with that branch of the tree, but let's keep going with 4. 4 is 2 times 2. All right, now we have the prime factorization of 8. It's 2 times 2 times 2. So let's write this up here. So we're working with a square root, so we're looking for pairs of numbers. I see a pair of 2's here. So we found one. We found the perfect square that lives inside of 8. It's 4. Because see, we could rewrite this as 4 times 2 if you wanted to. You don't have to. Some people like to do that so they can sort of see, oh, this is the perfect square. This is the one I'm going to take the square root of. But you don't have to. You can leave it as the 3 2's, circle your pair, and then just like all the other examples, when you find a pair, it comes out. So that 2 is going to come out. We can take the square root of 4. The square root of 4 is 2. Bring it out. But this time, check it out, there's something left over. This 2 is still underneath the radical, so it has to stay there. That 2 right here did not have another pair with it. It was all by itself. It was one single 2. There was no other 2 to pair it with. So the square root of 8 simplifies to 2 root 2. If you don't believe me, I'm sure, I'll show you. I'm not saying you shouldn't believe, you should always question me, right? You should always question your teachers, always. We're known to make mistakes, we're human, right? So let's practice this. Here's our graphing calculator, our Virginia version. Come down here to this, what do you call it? Keypad, and we're gonna click on the square root of 8. There it is, 2.828. What about 2 square roots of 2? Yep, sure enough, it's the same thing. So while you can't use the calculator to get this answer, right? We had to use our mind to simplify that. You can still use the calculator to confirm it's correct. And I highly suggest that. So do the hard work, of getting it simplified and then go ahead and check your work with the calculator. It doesn't hurt. Okay, you guys want to try another one? You're not here to tell me no. I'm excited. These are fun to me. Okay, so let's try square root of 18. So at first glance, you might not realize, but 18 is not a perfect square. So we have to find a perfect, whoa, this is very diagonal. One second. So we need to find a perfect square within it. So let's come over here and do a factor tree. So 18, what times what? I don't know. I just thought of 6 times 3. You could do 2 times 9. We're going to get the same answer at the end. We're going to keep factoring these numbers until we get a bunch of fruit, right? Keep going down these branches. 6 is 2 times 3. So there we go. There's the prime factorization of 18. It's 2 times 3 times 3. So let's write 2 times 3 times 3. Now this is a square root. So again, the goal is to find pairs of numbers, two numbers that match. Here they are. Ta-da! 3 times 3 is 9. Again, some people like to write it like that so they see that perfect square. You don't have to. I tend to just go right from here because I found that pair of numbers, so I know I'm going to take it out. This pair comes out front, and then what's left? In this case, it's a 2. So we could do the same thing here. We know square root of 9 is 3, so that will come out. And we're left with a 2 underneath. So square root of 18 reduces to 3 root 2, or simplifies. It's just like the most basic, simplified way to write the number, write that radical expression, without writing it as a decimal. It's more accurate. All right, we just got some more examples coming. How about the square root of 50? Why don't you guys try this one on your own? So we'll do our factor tree of 50, which is, I think of 2 times 25. 2 is prime, so we're done there. And then 25 is 5 times 5. All right, now we have our prime factors here. I'm not sure why I circled 25. 25 is composite. 25 is not prime. I'm only trying to circle the prime numbers. We kept going with 25. So here's our prime factorization. You don't have to do this factor tree. If you can look at 50 and write what you know equals 50, you can totally do that. If you're using your calculator to help you figure out what times what is 50, you can totally do that. I just like the trees because they always work. Especially as our numbers get bigger, we're going to be thankful for the trees, I think. All right, so our prime factors are 2 times 5 times 5. And again, we're doing square roots. We should do some cube roots soon. We found a pair of 5s. So you could write this as 2 times 25 if you want to, if you like seeing that perfect square there within 50. We know that a pair of 5s comes out, or we have a pair, so 1 5 comes out and the 2 gets left over. 2 gets left over a lot, huh? Very common, I suppose. 2 is a factor of a lot of things. Let's try one with a variable. Let me get a different color to sort of, how about 32x to the 5th. So let's come over here. We know 32. Actually, I'm just going to do it right here. 32. What times what is 32? I just start to think of, does 2 go into it? And I am actually going to use my calculator. Why not? We have it. So what times 2 is 32? And that's 16. Maybe you already knew that. 2 is done. 16 keeps going. 2 times 8. 8 keeps going. 2 times 4. This is a long one. And 4 keeps going, 2 times 2. So you want to take those numbers down as far as they'll go. And it looks like we have 1, 2, 3, 4, 5 2's. 1, 2, 3, 4, 5. And then we have x to the 5th. So I'm going to write that out as well. That's 5 x's. 1, 2, 3, 4, 5. Okay, so we're looking for pairs of numbers or pairs of things. Here we have a pair of 2's, and we have another pair of 2's. Oh, that little 2 is on his own. We have a pair of x's, a pair of x's, and that x is on his own, or her own, their own. All right, so now let's go ahead and take out the square roots. Let's do that operation. This first one here, the square root of, that would be 4, right? A 2 comes out. Here, the second group of 2's, another 2 comes out. This guy's going to stay. We have a pair of x's, so 1 comes out. Another pair of x's, so 1 comes out. And that x stays. So remember to write anything that's left over under the radical. And then this is certainly a fine answer, but typically you're going to see it more simplified. So 2 times 2 is 4, and x times x is x squared. So you're going to see it written like that. So we handle simplifying radicals with variables the same way. You find those pairs of letters, those pairs of variables, and you perform the square root operation. And when you perform that operation, that pair comes out to be one single number because the square root of 4 is 2. That's why. Now, some people say, well, it just magically disappears. And not really. We're taking the square root of the 4 in this case, and it is 2. All right, so hopefully you're getting excited. This is getting interesting. Let's do some more. How about 80p cubed? Square root of 80p cubed. So the approach is the same. Let's come over here. What times what is 80? 2 times 40. 40 is 2 times 20. 20 is 4 times 5, right? Yeah. 4 is 2 times 2. So all the numbers that can't go any further, those are the ones that get circled. Let's just make sure this is right. That's 4, 8, 16. Yeah, okay. So I like to write them in order of least to greatest. Kind of allows us to group our numbers together. And then we'll write the variables. So p cubed, that means there's 3. So this is a square root. We're looking for groups or pairs of numbers. Here's a pair. Here's a pair. And here's a pair. So when you find those pairs, we can go ahead and perform the square root operation and take them out. So this first one is 4, right? 2 times 2 is 4. Square root of 4 is 2. 2 times 2 is 4. Square root of 4 is 2. This 5 is going to stay. We don't have a pair with him. P, there's 2 p's there. Square root of p squared is p. 1 comes out. And the p will stay. So we have 5p left under the radical. So you're left with 4p on the outside and 5p on the inside. There we go. That's your answer. All right, let's try one more. I have 45p squared x cubed. So you can have more than one variable under the radical. It's okay. You're going to treat it the same way. So let's get our factors of 45 if you don't already know them. That's a 9 times 5. 5 is prime. And 9 is 3 times 3. There we go. So we have 3 times 3 times 5. And then we're going to pull out these variables. There's 2 p's, so I'm going to write 2 p's. That's the squared there. And 3 x's. Boop. 1, 2, 3. All right, square root. So we're looking for pairs of things, pairs of numbers. Here's a pair. 5 is alone, here's a pair, and here's a pair. So now we can take the operation. The square root of 9 is 3. One of those comes out. 5 will stay. 1p comes out. 1x comes out. And this x will stay. So we have 5x under the radical. And this is your answer. Now, we haven't done these at all yet, and I'm sorry that I was kind of hyper-focused on square roots there, but we can do the exact same thing with cube roots. Let me grab one. How about 80p cubed? Let's do that. Cubed root. So the process is the same. We're going to factor tree it. I know we just did this, but 80 is 2 times 40. 4 times 10. Oh, look, I'm doing it a little differently. Just depends on what factors you think of, but you'll always get down to the same prime factorization list. So we have 1, 2, 3, 4 2's, and a 5. 4, 8, 16. Yep. And then 3 p's. Cube root. So instead of looking for pairs of items, now we're looking for groups of 3 because it's a cube. So here's 3 2's. That 2 will stay. That 5 will stay. Here's 3 p's. Cool. So we found a group of 3 2's. One comes out. And then we found a group of 3 p's. One comes out. And we're left with whatever is underneath the 2 and the 5. There we go. So you're going to see this written as 2 times 5 is 10. You can go ahead and combine those. There we go. I don't know, you guys. I know that I'm I'm a math teacher, right? I think it's fun. I think these are a lot of fun because it's kind of like a puzzle. You know, we start with this and we're trying to work our way through the problem to get into a more simplified version. And they're going to get even more fun as we get into radical operations. So like adding and subtracting and multiplying and dividing radicals. We're going to do that tomorrow in live class. So if you guys want a little bit more practice on this, I do have a class kick for you. I'm going to put this link in the play pause it question for you to click on. If for some reason you're watching the view pure, obviously you won't be able to click on the link, but you can go ahead and go to classkick.com. Classkick. It's a general web link, www, and you can put in this class code. You don't have to log in. You just type your first name, last initial, and it will take you right to that ClassKick screen. We've done this in class before. This is not required. This is optional. It's called extra practice. Totally optional, but it's reviewing what we did today in this play pause it, and there is an answer key to confirm your work. All right, you guys. If anybody knows who this actor is or what this scene is from, tell me tomorrow. Oh, I love this show. Okay, I'll see you tomorrow in class. Reach out if you have any questions. There are a few important announcements in your plan for today. Make sure you take a peek at those. One is a survey I'm hoping you can fill out, and then another one is just a message about any requests that you've sent me over email. I just want to make sure everyone's been responded to because of the email outage. So if for some reason you've emailed me in the past few weeks and you never heard back, please reach out again, like just re-forward that email because I just want to make sure there were no loose ends with that. All right, you guys, thanks for listening. Have a great day. I'll see you tomorrow.